now that we've seen the basic concepts of the abstract machine, let's take a look at an actual execution in the abstract machine. So here, let's take a look at a simple instruction. Here's a very simple one. Doesn't do very much, but it will show us exactly how the abstract machine works. So this instruction has some local instructions inside. It has a binding, it has a conditional. So let's see how it works. So the way we start is we have to set up an initial execution state. And the way we do that is we have to give here an empty environment, and we have to give it an empty memory. Okay, so we've created now an initial semantic stack here with one instruction on it, which is a semantic instruction containing the actual statement and the empty environment, and we pair it with the memory, an empty memory, which gives us the execution state. Okay, and now what we do is we take off the first instruction off the top of the semantic stack, and we look at it and we execute it according to what instruction it is. So in this case, it's a local instruction. So we go on, we do local xin. So the local xin instruction, what it does is it creates a new variable in memory, little x. It puts its inner instruction, which is a local bin end, on the semantic stack, and it with a new environment, which is the old environment, and an additional link connecting the identifier big X with the variable little x. So again, we have a single instruction on the semantic stack. The next execution step will take off this instruction, the local B instruction, and we'll again do an execution. So the local B instruction will create a new variable B in memory, very similar to the local X instruction. It will put its inner instruction on the semantic stack, and it will add a new link B referring to little b on the environment, and then it continues with a third execution step. Now the third step is a little bit subtle because there exists now one instruction on the semantic stack, but this one instruction has two instructions inside it. It's called the sequential composition. So what happens is we take this one instruction off the stack, the sequential composition, and we look at the two instructions which are inside, and we split the sequential composition into its two parts, and we put them both on the semantic stack. So the semantic stack now has two elements. The environments for these both of these instructions are the same. They have not changed. So now we have two instructions on the semantic stack. The next step will take off the top instruction, which is the b equal true, to execute it. So this instruction will bind b to true in the memory, and that's all it does. And then we have a semantic stack with one instruction, which is the if. What this one will do then is take the if off the memory, and then it will do the conditional. So the conditional will read the value of b. This corresponds to variable little b. Since little b is equal to true, this will put the instruction after the then on the stack. Now, so that's the x equal 1. Now let me explain what would have happened if b would have had another value. If b would have been false, it would have put the instruction after the else on the stack. That would have been a skip. If b would have had any other value other than true or false, that would be an error, and we would raise an error condition using a concept called exception, which we'll see later in the course. And there is yet a fourth possibility. What happens if b is unbound? What happens then? Well, if that occurs, then we cannot continue the execution of this semantic stack. We cannot do the if because we don't have enough information to decide whether it's the then or the else. So the execution of this semantic stops until b becomes bound. When can that happen? It can only happen in another semantic stack. That means if we have concurrent execution. So this is how we're going to implement the basic synchronization of data flow concurrency. But that's all I want to say about that for now. I don't want to get too much out of myself because we're still going to have a few lessons on sequential execution. So the next instruction to be executed is x equal 1. So we remove it from the semantic stack, and we then execute it, which binds x equal to 1 in memory. Notice that the semantic stack is now empty. That means execution stops. We have termination of our program. So what we have seen in this example is 4 instructions. The local instruction, which is called variable creation, the sequential composition instruction, the conditional instruction, and the assignment instruction. So we've seen examples of this. In the next unit, we will see the actual semantic rules that correspond to this execution.